So, yesterday we learned about linear means two isotropic point sources. Okay, equal amplitude point sources, N-fire array and all. So today we are going to discuss about linear array of N isotropic. Okay, N isotropic point sources. So it is linear array. Okay, linear array with the n isotropic point sources. N isotropic point sources. So it is an array of n elements. Okay, of n elements which are spaced equally. Okay, the space separation D is equal and is uniform. Okay, they are spaced equally in a line. Okay, it is linear array, so they are spaced equally in a line. Okay, so it has same amplitude and uniform progressive phase shift along the line. So it has same amplitude and what? Uniform phase shift. Okay, uniform phase shift progressively along the line. Okay, so it is progressively, the phase shift is uniform along this line. Okay, so it has same amplitude and uniform phase shift along the progressively along this line. Okay, so therefore the total field pattern. Okay, so what it is said that there are n isotropic in linear array of n isotropic point sources. There are n elements which are equally spaced. Okay, which are equally spaced in a line. Okay, with equal and what? Same amplitude and uniform phase shift. Therefore, what is the total field pattern at a distant point P? At a distant point P, the total field pattern, we are indicating the field pattern by its amplitude. Okay, so Et equal to E1 plus E2 plus E3 plus etc. En. Okay. So there are n isotropic point sources. So up to n you write. So what is E1? What is E1? E1 is E naught e raised to E naught e raised to 0j psi. Okay, E naught e raised to 0j psi, because what? E1 up to n you have taken. So 0 up to n minus 1 will be the above the index. Okay, so here the suffixes are from 1 to n. So the indices will be what? From 0 to n minus 1. Okay, so E0 e raised to 0j psi plus E0 e raised to 1j psi plus etc. plus E0 e raised to n minus 1 j psi. Okay, E0 e raised to n minus 1 j psi. So, can we take anything common from here? So, E naught is taken common. Okay. So e raised to 0 j psi means what? E raised to 0, which means what? 1. Okay. 1 plus e raised to j psi. Okay. Plus etc. plus e raised to j n minus 1 psi. Okay. So this is first equation. Then you multiply this first equation by e raised to j psi. Okay, e raised to j psi. So this is Et. Okay, the total amplitude. Okay, the total amplitude or the total field pattern. The total field pattern at a distant point P. Okay, so at a distant point P due to each and every point sources. Okay, these are the point sources, isotropic point sources. So the total field pattern at a distant point P due to each and every point sources is given by this equation. Et equal to E1 plus E2 plus E3 plus etc. plus En. So this equation 1 into e raised to j psi. So we multiply this first equation by e raised to j psi. So what will we get? E naught into this 1 will become what? E raised to j psi. This e raised to j psi will become what? E raised to j 2 psi plus etc. plus e raised to j n minus 1 psi becomes what? E raised to j n psi. Okay. So this is second equation. So we subtract second equation from first equation. Okay, so this LHS is what? 1 into e raised to j psi means Et into e raised to j psi. Okay, this is the LHS. Et into e raised to j psi. So 2 minus 1 means what? Et into e raised to j psi minus 1. Okay. This is Et into e raised to j psi, this LHS. Here Et. So 2 minus 1 means Et into e raised to j psi minus 1. Equal to what? E naught into what? E naught into, what is this term? E raised to j theta plus e raised to j 2 theta plus etc. plus e raised to j n theta. It is nothing but e raised to j n theta. Okay. E raised to j n theta. Okay. So theta means what here? Psi. Okay. So e raised to j n psi minus 1 by what? E raised to the E naught by what? E raised to j psi minus 1. Minus 1. Okay, minus 1. So Et is what? Et is equal to E naught into e raised to j n psi minus 1 by e raised to j psi minus 1. Okay. So next equation is what? So this n psi, e raised to j n psi, how we can write? E raised to j n psi by 2 e raised to j n psi by 2. So e raised to j n psi by 2 plus j n psi by 2 means e raised to j n psi. Okay, so e raised to j n psi minus 1 we can, how we can write? E raised to j n psi by 2 e raised to minus j n psi by 2. J n psi by 2 minus j n psi by 2 gets cancelled. So e raised to 0, 1. So divided by what? E raised to j psi, similarly e raised to j psi by 2, e raised to j psi by 2 minus e raised to j psi by 2, e raised to minus j psi by 2. Into E naught is what? E t. Okay. So from here, what term we can take outside? E raised to j n psi by 2 and e raised to j psi by 2. So E naught into what? E raised to j n psi by 2 by e raised to j psi by 2. Okay. Into what? Into e raised to j n psi by 2 minus e raised to minus j psi by 2 n psi by 2 by e raised to j psi by 2 minus e raised to minus j psi by 2. Okay. So what is this term? E raised to j theta minus e raised to minus j theta. 2j sine theta. Okay. So 2j n sine n 2j sine n psi by 2. 2j sine n psi by 2 by 2j sine psi by 2. Okay. E naught e raised to j n psi by 2 by e raised to j psi by 2. So, what is this equation? 2j and 2j gets cancelled. Finally, what will we get? E naught e raised to n j psi by 2 minus j. Okay. E raised to n j psi by 2 by e raised to j psi by 2 means what? E raised to n minus 1 j psi by 2. Okay. E raised to n minus 1 j psi by 2 divided by, so minus e raised to n minus 1 psi by 2. So sine n psi by 2 by sine psi by 2. Okay. So this is the final equation. So next we are considering broadside case. Okay. Why broadside case? Equal amplitude and phase, which case is coming? Because equal amplitude and equal phase, uniform phase is nothing but broadside array. So broadside array is the first thing. Next we can, after that we will consider what? End fire array. So this is broadside case. Broadside case. So equal amplitude and spacing. Okay. Equal amplitude and spacing. So what? An array is said to be broadside if the phase angle is such that it makes maximum radiation perpendicular to the line array. Okay. So what is the maximum radiation? Maximum radiation. It is perpendicular to the array. Okay. It is perpendicular to the line of array. That is 90 degree and 270 degree. Okay. 90 degree and 270 degree. This is theta minimum. I have told you earlier. This is nothing but broadside array. Okay. So this is the major lobes. Okay. This is a radiation pattern and theta maximum at 90 degree and 270 degree, which means it makes maximum radiation perpendicular to the line of array. This is the line of array. Okay, so it is perpendicular to the line of array. Total phase angle is what? Psi equal to beta d cos theta plus alpha, where alpha is the additional phase shift. But here this additional phase shift term equal to 0 in the case of broadside array. Okay, so psi is nothing but beta d cos theta plus alpha, where alpha is additional phase shift, and here the additional phase shift in the case of broadside array is 0. So principal maxima is where? At 90 degree and at 270 degree. Next is what? Pattern maxima. Minor lobes. Okay. Next we are discussing about pattern maxima in the case of minor lobes. So, ET is equal to what? So, E naught. Okay. The other term. Here ET was what? E naught into e raised to j n minus 1 psi by 2 sin n psi by 2 by sin psi by 2. So, here this term will be what? Maximum, which means 1. So, ET norm is what? ET norm is normalized, which means maximum is nothing but sin n psi by 2 by sin psi by 2. This term is maximum where? Where it is maximum? This term is maximum when the numerator, okay, when the numerator is n psi by 2, sin n psi by 2 equal to 1. Sin n psi by 2 equal to 1. Okay, maximum value means numerator is 1. By denominator, provided what? Denominator must not be equal to 0. So, sin psi by 2 not equal to 0. Okay. So, sin n psi by 2 equal to maximum means equal to 1, provided that sin psi by 2 not equal to 0. Because if denominator is 0, it is not valid. Okay. So, n psi by 2. So, this is what? N psi by 2 equal to 1 means what? Sin value is 1, which means this n psi by 2 is nothing but 2 into sin 90 is 1. Okay. So, 2 into n plus 1 plus or minus 2 into n plus 1 pi by 2. Okay. N plus 1 pi by 2. This is due to minor lobes. Okay. N plus 1 pi by 2, n equal to 1, 2, 3, etc. Okay. So, n psi by 2 equal to 2n plus 1 pi by 2, where n equal to 1, 2, 3, etc. So, psi is equal to what? So, n psi by 2 is equal to this term. So, psi is equal to 2 gets cancelled. 2n plus 1 plus or minus 2n plus 1 pi by n. Okay, 2n plus 1 plus or minus pi by plus or minus 2n plus 1 pi by n. N plus 1 pi by n. So, this is what? Beta. Psi is what? beta d cos theta. Beta is what? 2 pi by lambda. D is assumed as what? Lambda by 2. Cos theta. Okay. Equal to plus or minus 2n plus 1 pi by n. So lambda gets cancelled 2 pi cos theta equal to plus or minus 2n plus 1 pi by n. Okay. So cos theta equal to what? Pi gets cancelled plus or minus 2n plus 1 by n. Okay. So what we can write about theta max? This is maxima. Okay. This is, I am discussing about maxima. So what we can write about the maxima? Theta max or phase shift maximum of the minor lobes. Minor lobes, theta max is nothing but what? Cos inverse plus or minus 2n plus 1 by n. Okay. So we are taking we are taking one special case. Okay, which means here the value, to get the value, to get where is approximately the value comes, because there are two unknowns. Okay, n is there and small n is there. So we take the value of small n as what? Small n is equal to 4. Okay. D equal to lambda by 2. Small n and capital N, two values are being given. Okay. So small n is equal to 4, d is equal to lambda by 2. So n is what? N is equal to 1, 2, 0, 1, 2, 3, etc. So, sorry, n is equal to 1, 2, 3, etc. So n capital N, we take it as 1. So what? Cos inverse plus or minus 2 into 1. Okay, 2 into n plus 1. N is what? 1. Plus 1, 2n plus 1 by n. N small n is what? 4. Okay. So cos inverse 2 by 4. Cos inverse 1 by 2. What is the cos inverse 2? 2 plus 1. 2 plus 1, 3 by 4. Cos inverse 3 by 4. So what is the value? Cos inverse plus or minus 3 by 4. What is the value? You do in calculator and you will get that 41.09 degrees and 138.59 degree. Okay, so this is the angles, phase shift. So now we are discussing about pattern minima. Okay, pattern minima. So this is minima when numerator equal to 0. Okay. So I told you earlier sin n psi by 2 by sin psi by 2 equal to what will we get? When minimum. Okay. So it should be minimum when numerator equal to 0 provided denominator not equal to 0. So because 0 by 0 is not valid. Okay. That is when numerator equal to 0 and denominator not equal to 0. So what? N psi by 2 equal to what? Sin n psi by 2 equal to 0 means what? Sin n psi by 2 equal to 0 means n psi by 2 equal to what? Plus or minus n pi. Okay. Plus or minus n pi. Because sin is 0 when it is an integral multiple of pi. Okay. So n is equal to 1, 2, 3, etc. So psi is equal to what? plus or minus 2n pi by n. Okay. So, psi is what? Beta d cos theta is equal to plus or minus 2n pi by n. So, theta minimum minor. Okay. We are discussing about minima. Theta minima minor lobes. Okay. Is equal to what? Cos inverse plus or minus 2n by small n. Okay. Because what? Beta d cos theta equal to what? Pi cos theta. Pi cos theta. Pi and pi gets cancelled. So cos theta equal to plus or minus 2n by n. So theta is equal to what? Theta theta minimum minor is nothing but cos inverse plus or minus 2n by n. Okay. So theta minimum, there are two cases. Okay, we are taking two cases. Case 1, when n is equal to 4. Okay, when n is equal to 4, d is equal to lambda by 2, n is equal to 1. Okay, d is taken every time as lambda by 2 and n is equal to 1 because 1 starting as 1, 2, 3. Okay, so n is equal to 1 and what? N is equal, small n is equal to 4. So theta minimum minor lobes is equal to cos inverse plus or minus 2n into 1 by 4. Okay, cos inverse plus or minus 1 by 2, 60 degree and 120 degree. So it is nothing but 60 degree and 120 degree. Cos inverse 1 by 2. Okay, cos inverse 60, cos 60, 1 by 2, cos 120 degree minus 1 by 2. So next is case 2. We are taking two cases in order to approximate the values of these minor minima, where these approximately these minimas of these minor lobes are coming. So theta minima minor is what? In the case of case 2. Case 2, we are taking the values as n is equal to 4 and capital N is equal to 2. So we are getting cos inverse plus or minus 2 into 2 by 4, which means cos inverse plus or minus 1, which means what? Cos 0 is 1, okay, and cos 180 degrees minus 1. So 0 and 180 degree. So next is what? So you write this theta minimum minor and theta maximum minors in beta term, beta d term. So how will we write? Theta maximum minor. Because what? Beta d cos theta equal to 2n plus 1 pi by n. Okay, 2n plus 1 pi by small n. So theta max minor is what? 2n cos inverse 1 by beta d. Okay, this beta d is taken here. So 1 by beta d cos inverse plus or minus means cos theta equal to by beta d. Okay, so the beta d doesn't come here. Beta d is in the bracket. Okay, 1 by beta d plus or minus 2n plus 1 pi by n. Okay. Next, theta minimum minor lobes. It's equal to what? It was what? Beta d cos theta equal to 2 pi by n. 2n pi. 2 pi n by n. Okay. So, theta minimum minor is nothing but cos inverse 1 by beta d 2 pi cos inverse 1 by beta d plus or minus 2 n pi by n. 2n pi by n. So this is an odd multiple and this is an even multiple. So minimum is an even multiple and maxima is nothing but an odd multiple. That you remember. So roll number 1. Attendance. Okay. Roll number 2.
Present, Miss.
Roll number 3.
Present, Miss.
Roll number 4.
Present, Miss.
Roll number 5.
Present, Miss.
Roll number 6. Roll number 7.
Present, Miss.
7. Roll number 8.
Present, Miss.
Roll number 9.
Present, Miss.
Roll number 10.
Present, Miss.
Roll number 11.
Present, Miss.
Roll number 12. Roll number 13.
Present, Miss.
Roll number 14.
Present, Miss.
Roll number 15. 15. Roll number 16.
Present, Miss.
Roll number 17.
Present, Miss.
Okay, present. Roll number 18.
Present, Miss.
Roll number 19. 19.
Present, Miss.
12 present. 15 present. 19 present. 20. 20. Saumya. So absent is 6 and 20. Absent is 6 and 20. Okay, Allah. 6 and 20.